Okay, we've been given a geometrical problem here with seemingly very little information on it, but the information is very subtle and we're asked to look at the ratios of the triangle to the area of the square. So let's start by putting that information on the diagram. So we're told that the triangle is half of an equilateral triangle, which means that this angle here is 60 degrees. And this angle here, if we need it, is 30 degrees. And we're told that the sides of the square here are a quarter of AB. So if this side length was x and the length of AB is 4x, which means the length of this remaining bit here is 3x, again, if we need it. So that's put all the information that they've given us on the diagram. Let's see if we can now proceed. So first of all, might as well get it out of the way. The area of the square is equal to x squared. So given that we need to find the area of the triangle, I've marked this side, AC, as the length B. Base of the triangle, height of the triangle. Yes, I know it's all twisted 90 degrees and whatever, but let's call that the base and that the height. If I look at this angle, I can say that tan 30 is equal to the opposite over the adjacent, which is B over 4x. And we know that tan 30 is 1 over root 3, one of the standard angles. So therefore, B is equal to 4x over the square root of 3. So therefore, the area of the triangle is equal to half the base multiplied by the height, which is 4x. Always eager to cancel something away. That becomes 2. So this is equal to 8x on the top over the square root of 3. 8x squared, I should say. So therefore, the ratio of the triangle to the square is equal to 8x squared over the root of 3 to x squared. So we can remove the x squareds and we can say this is 8 over root 3 to 1, or 8 to the square root of 3. And that's your answer.